Hi folks, this is Calc 2, Checkpoint Quiz 7. We're given some integrals to deal with here. In number 1, we're first asked to integrate arcsine x dx. And so since this doesn't fit any of the basic formulas we know from previous work, we're going to try one of these new techniques. We'll try integration by parts. So the integration by parts formula is the integral of u dv is uv minus the integral v du. So to get the ball rolling with integration by parts, I need to make choices for what u is, and then everything else is going to be the dv. Now we have this rule of thumb, the Lyate rule, which gives us a rule of thumb for the pecking order here. Log, inverse, trig, algebraic, trigonometric, and exponential. So this is the order of precedence. And as I look in my integral, I've got arcsine, and arcsine we've considered an I, that's an inverse trig function. So I'm going to let u be the arcsine of x. So in that case, the du is 1 over the square root of 1 minus x squared dx. So since that's the u, the dv is everything else. In this case, we just have the dx. So I integrate to determine v, and I get x, and as usual, I suppress the constant of integration. So what's this integral equal to? U times v, which is x times the arcsine of x, minus the integral v du, which would be x times that, which would give me x divided by the square root of 1 minus x squared dx. So the hope with integration by parts is that the integral that you end up with is somehow easier than the one we started with. Okay, so let's take a look at this integral now. So we've got the integral of x divided by the square root of 1 minus x squared dx. And to our surprise and or delight, I can rewrite this as a Calc 1 integral, x times 1 minus x squared to the minus 1/2 power. So I can solve this using a basic substitution. I've already used a u, so I'm going to use w then for my substitution. So the dw is minus 2x dx. So I can account for this negative 2 that I need, because I've got the x dx there, by putting a negative 1/2 out front. So as usual, we pick up this constant out front, and then I'm going to have w to the minus 1/2 power dw. So I integrate this, I get minus 1/2. And the integral w to the minus 1/2 dw is w to the 1/2 power divided by 1/2 plus c. So this is negative w to the 1/2 plus c, which in terms of x's is negative 1 minus x squared to the 1/2 plus c. So now I take this and put it back up into my original formula here, and I get the integral arcsine x dx is x arcsine of x minus this integral, which I've determined to be this. That's going to give me a plus 1 minus x squared to the 1/2 power plus the arbitrary constant. Okay, now we can check the answer by taking the derivative, and remember, anytime you use integration by parts to find an integral, the derivative is going to involve the product rule. Okay, so that'll do it for part A. All right, in part B, I'm looking at the integral of x squared e to the 2x dx. Once again, this would proceed by parts, but this is a special kind of parts. Each time I would run through the integration by parts, I would be letting u be the x squared, because that's an algebraic function. And as I look through the hierarchy here, the algebraic function would take precedence over the exponential function. So, as I look at this one, I've got one factor whose derivative eventually goes to 0, and the other factor who I can integrate as long as I need to. So this means I can use the tabular method. Tabular method, once again, is a rapid way to do multiple integration by parts. And it's designed for integrals like this, where one factor has a derivative that eventually zeroes out, and the other factor you can integrate as long as you need to. Okay? So to do the tabular method, we start off with a column for the u's and the dv's. And for the u's, we're going to take derivatives all the way down. And for the dv's, we're going to integrate all the way down. So we start off, the u is x squared. I take the derivative of that, I get 2x. I take the derivative of that, I get 2. I take the derivative of that, I get 0. All right, and then I stop. For the dv, it's e to the 2x. Integrate that, I get a half e to the 2x. Integrate that, I get a quarter e to the 2x. I integrate that, I get an eighth e to the 2x. All right, now I think the integration by parts formula, the integral of u dv is uv minus the integral v du. So it's going to be, this was my u, this was my dv, so uv is going to be that. And I'm subtracting the integral of v du. So I would be multiplying then, this would be the new u, that's the new v, subtract, new u, new v. And since I'm subtracting each time, these get assigned a positive 1 and negative 1 as I go down. This is for the first subtraction, but when I subtract a subtraction, I get an addition. All right, so this lets us write down the answer. The integral x squared e to the 2x dx is plus 1 x squared 1/2 e to the 2x plus a negative 1 times 2x times 1/4, oops, getting a little sloppy here, times 1/4 e to the 2x plus positive 1 times 2 times 1/8 e to the 2x plus c. And I suppose I can write my final answer then as x squared e to the 2x over 2 minus x e to the 2x over 2 plus e to the 2x over 4 plus c. And you're invited to take the answer by taking the derivative. And since we've effectively done integration by parts twice here, you're going to see we have two product rules we have to take care of. That'll do it for part B. All right, part C, the last one here, we've had a couple intense examples. I look at this, and even though it's hauntingly similar to the one above it, all right, all I've done is switch the places of the x squared and 2x. This, in fact, is a basic substitution. If I let u be what's in the exponent, x squared, the du is sitting right out front. So in the land of u, I'm just integrating e to the u du, which is e to the u plus c, which in the land of x's, it's e to the x squared plus c. And we can check this easily using the chain rule by taking the derivative and showing it's equal to the integrand. And that'll do it for part C, and that'll do it for checkpoint quiz 7.